All right, and before we start the lightning rounds, I just want to quick shout out to the Unconference. We've nailed down the date and the venue for November 21st at GAFTA. So if you were there last year, it was a lot of fun. We had about 100 people. This year we're doing 150. It's a little bigger. The space is a little bigger. It's a historic theater that's been renovated in the Mission, like 5,000 square feet. It should be really cool. We haven't started selling tickets or anything yet, but there is a mailing list you can get onto on bizfest.com to hear about it first. We're trying to keep it really to like people that are practitioners of D3. So it's going to be everyone there has at least like made a block and tried to make some data viz, and so it'd be like a concentrated fun time. So just want to make that aware. So if you were planning to leave early for Thanksgiving, you stay for this Saturday and then go eat some turkey or something. All right, so Curran, you want to kick it off real quick?
Yeah.
All right, go for it.
Hi, everyone. My name is Curran, and I'm working on this project called Chiasm, which is like for reusable visualization components and connecting them together. And there's a bunch of fresh examples here. And I finally feel like I've nailed down this API, which is like an alternative to the towards reusable charts thing, where you can have this nested box layout thing and then link things together and have everything be interactive. So these are SVG elements, and this is a canvas element. And I tried to do a bunch of work in black and white to sort of show fundamental things, So this is one where like these are images from this classic paper from I think 1984 that just show like basic visualization techniques. And then here's a version where they are actually implemented as these D3 modules. And so this is one scatterplot module that's configured in two different ways, and this is one module that's configured in two different ways, and so is this bar chart thing. It's missing legends. And then I wanted to show interaction techniques. So here's one that is basically a copy of an existing D3 example, but it's using this framework. And it's like focus plus context with brushing. And there are lines that connect the two together to show you the focus plus context happening. And then there's also a variant of that with scatter plots, like this. So it's pretty much the same thing, but with scatter plots. And also I managed to do a cross-filter integration, a proper cross-filter integration. So this is, theoretically, you can connect the cross-filter stuff to any visualization component in this framework. And then I wanted to experiment with Leaflet, this mapping library. So here's this map and globe thing, where this is a leaflet map on the left and a D3 globe on the right. And you can interact in both of them, and you can see the distortion. And the distortion, like the representation here is kind of weak, right? It's just a circle, but you're actually looking at a square. And so I put this out there and said, hey, does anybody know how to make this into a square? And so this guy, I don't know him, but he made it work. So that's pretty cool. So you can see the actual square distortion of the Mercator projection. And so as you sort of zoom in and out, you can really see how it distorts. Right? It's pretty wild. But
all right, you want? So I also saw this on the mailing list and thought to myself, I have to give this a shot. But I wanted to sample, so not just a rectangle, but individual points. And so here, this is showing a projection that was, I believe, designed to show Africa pretty well. But if you show like anywhere else, you see the distortion. I also riffed off some other blocks that compared different projectors. So here's our projections. Mercator, some ones that I've never heard about. And then the other day, I went even further, because it's not just rectangles that you can distort. you can sample an image. And his beard can't save him now, right? So, he favorited one of the tweets, yeah. So he's seen it. He didn't, yell at me. But some crazy stuff happens in the math. Yeah, and then real quick for my show and tell before I hand it off, I built this project called Building Blocks. I demoed it for the first time in the public last week at the Oakland meetup. And it's essentially a tool for forking, editing, and creating blocks without having to use the command line. So it works straight in the browser. So we have here the same block that we were just working on, but the code here is editable. We can also move it to the side, although it's built so that this is always 960 pixels wide, so at this resolution it's not quite as useful. Well, let's see if there's something I can change the path. Radicule, maybe we can make the color so that I'm making those lines darker. The land, this thing is like,
so like a code pen, but for D3.
Exactly.
That's awesome.
For D3 blocks, and you can. I'm making the land on the left side green, right? So behind his face. So anyway, then you can, if you're logged in GitHub, you can fork this into your own account once you've made the modifications, or you can save it if it's already your block. And then you can also, if you just create a new block, the home page is the interface for just writing some code. By default, it includes D3 for you. And there's a little overview video that will go away as soon as you start typing something here. So check that out. It's all open source as well. And I hope everyone makes many more blocks.
Good evening. James and I are from GE's Global Research Organization. And we work in the San Ramon office. And we work on industrial applications for helping people understand how to understand the data that comes off all of the GE's assets. And so this tool here is, you want to kind of speak to it?
Oh, yeah.
It's only 2 minutes, so keep it short.
Yeah, so this is a tool that we are building in the building. Basically, allow for putting different type of widgets in this space, and then so all the capability like linking and brushing will happen in the browser or across browser. So we can build an application like for data science in one location to work with domain expert in the other location, and where the linking and brushing will be able to go across browser, across devices. And while you are looking at this, one of the older example we built about 3 years ago, so we can share it without being blamed by the company. So while you are looking at this, like 6 years of outage happened on the energy grid in this area, and the idea is the data scientists or the company, they want to be able to figure out, if there are, for example, certain type of weather pattern under a certain time frame associated with certain part of the grid around certain location, and typically severe outage will happen. And if they will be able to figure out a few key patterns like that across different domain of data, then basically we are building those type of patterns into a machine learning algorithm, so they'll be able to do the predictive maintenance, as you can imagine. So here what Carl was showing, for example, the color coding that we are using, these are basically indicate how severe outage was, and then so luckily we put some nation here. And so, for example, if you want to look at the outage that are more severe as opposed to the outage that are pretty light, and through linking and brushing, we'll be able to do that. And then some of the use cases are like, the outage that happened during the winter time, and then particularly when there are snow coming down, and then usually those type of outage cost them a lot of money to fix, and then they're trying to figure out those kind of outage, do they happen in certain area of the grid? And then let's say, suppose, these are one of the area of interest, and then as you see, we build, some of the overlay, some of the information on top of that, so to reduce the clutter on the map, because what we are visualizing here, there are in total about 300,000 devices on this energy grid area. So we use a little bit of the semantic zoom technique, and then so they will be able to see, all the way from the substation of the grid to the feeder line of the grid, and then to individual devices on the street block, and trying to figure out those type of pattern across heterogeneous data domain.
There's just two interesting things about this. One of them is this was usually one of the reasons it looks really small here is this is usually shown on a touch table that's about this wide, so it gets a better resolution for it. And the other one, which is really interesting about the system, it's called ICViz, is that when you work on this, you can be working in real time with another person remotely, so that they can actually see what you're doing at the same time. So instead of it being seen in WebEx and trying to tell somebody what's going on, you actually work with that other person, usually a subject matter expert.
Yeah, and using that kind of platform, we basically also build an application to support pilot in the sky and dispatcher on the ground, and be able to discuss, a route and then the change of a route due to the upcoming weather event. And as you can imagine, dispatcher look at the network of flight, while the pilot only interested in their own route and the neighboring route. And then so we passing the event there, doing the mirror screen. So in each of the visualization basically designed for their specific persona, while the event can pass around. So those type of application we build based upon this type of framework.
Is all that stuff done in the browser, or is all those, what you said, 300,000?
Oh, all in browser.
All in the browser.
Yeah, all in browser.
I have a different one, which is all the.
Does your browser take out?
Well, actually, that's a good question. There are some other techniques that we use to do either the server side or client side type of data aggregation, and then and transformation, and then so transform that from pure raw data domain to some type of image synthesize, and then so basically just try to reduce the number of data that the size
that goes to the browser
will be able to handle. But typically on the client side, we use browser.
Was all of that real-time data?
What you are looking at are not, but some of the projects that we are working on, they are.
Yeah, so one of the ones we have is it's called Rapid Data Forensics, and it looks at jet engines, and it looks at hundreds of jet engines over tens of thousands of cycles every time you turn the engine on and off. And it's what you're looking at is tens of thousands of cycles for hundreds of engines. We do a lot of work on the server and then move it into the browser when we have a visualization ready.
Yeah, and then so it's not real time. It's close to real time.
As close as we can get.
When the flight is still flying, they don't dump that kind of amount of data, too expensive. So when they land it, and then they dump.
So I was worried about the previous answer. Up to 300,000 data points, you actually put it in the browser and do all that processing.
Yeah, we do a little bit synthesize and aggregation, but yeah. That's pretty much the top of the level.
Server syncs also happening? Server syncs also happening?
In this example, not. But we sort of control the size. It's 6 years of event, and then around the device, 300,000 devices, but not all the devices has outage. Okay. So we are talking about only the outage. So it's kind of aggregated data then sorry?
It's aggregated based on the outages.
Yeah. Yes. And then also aggregate based upon, for example, the location proximity or the time proximity, right? So there are different type of aggregation that we do depending upon the data domain.
Then you reference this?
No. I'm sorry. We try very hard to show more, and then we love to learn people's comments and suggestions, and then these are a few of the examples that we could, but that doesn't let us to put it. Because these are all real data, and then it's from our customers.
We're allowed to show it, but we're not allowed to put the data out there.
Yeah, they are also afraid of something because these are all infrastructure data.
Cool. Great. Thanks.
Thank you.
Okay. Hi. So about a year and a half ago, I started wondering about. I'm this huge fangirl of a YouTube channel called Wang Fu Productions. And I've been a huge fan of them since like 2006 or something like that. And then around 2010 or 2011, I started noticing that they were collaborating a lot with their other YouTube channels. So about a year and a half ago, I was like, I really want to see what the shape of their collaborations look like. So I started working on this about a year and a half ago, and about a year ago, I actually showed my V2 or V3 at that time at one of these meetups, one of these D3 meetups, and then life got in the way, and then like it went on hiatus, and then recently I've been working on it again, and this is my V5. So if you ask like, is it gonna be online? About a year ago, I said it would be online soon. Soon, sometime soon. But essentially what's happening is each of these lines you see represents the activity of a channel. And then each of these are kind of nodes of the channel itself. And each of these lines show an aggregate of who has collaborated with who at that given time, whereas these lines are kind of showing you the snapshot in time. So this is back in 2009. So I think I start the timeline at about 2005. The collaborations are at least 2 channels together with at least 100,000 views. So I think this is actually the first one that shows up in 2008. And as I scroll, I should not have turned on the sound. Okay.
Turn it off.
Oh. Well, so I was gonna like show you the visuals first and be like, in V5, I figured out how to do sound. Yay. So. And because I'm not a musician and I know no music theory, it sounds very dissonant. I got some advice from Jason, who's like super hardcore classic violin player. So he's trying to help me make it sound better, but for now, this is what it sounds like.
Very Schoenberg.
Sorry, what?
Very Schoenberg. Schoenberg's.
My friend said it sounded very contemporary. I don't know what that means either.
Kind of like Schoenberg.
Is that a contemporary Schoenberg? So this is about, you notice like about 2010, in 2009, some people start coming together, and then in 2010, the collaborations really start kind of going like all together. And so there's like some of the interesting insights have been like there's pockets where they all collaborate together a lot and then they go back and do their own thing. And then there's sometimes like if you notice, for example, this one, they actually worked on a project together. So she comes over here onto this channel and stays for a while. The other thing that was really cool to notice is like some of them, it seems like they'll collaborate together on a different channel and then later on, like really soon after, they'll release a video together. So that was really exciting to see also. These circles are view count. And then so the most exciting thing other than the sound has been figuring out how to animate these lines. So they're animating based on scroll. So they're all being animated until like right this Y position. That was.
So what's the thickness of the lines in the lower diagram representing?
Yes.
Number of collaborations?
So number of collaborations together. So I haven't put in too much interactions yet. And I also need to put in legends. But no, this actually, like, I really do mean to. It wasn't just like I came to this talk and I was like, legends. But yes, the thickness of these lines is how often they've collaborated together. So this is really interesting. They're really good friends, these two channels. So they have in total, I think, 93 videos that they've collaborated on together. And then some of the other ones aren't as thick as this one.
And is that within a certain time frame or cumulative?
I believe it's cumulative. So one of the really great suggestions I got from Jason was to have kind of like a bar on the side that shows an overall view. So like kind of like an overall, like we were looking at Sublime at that time. So something like this right here, where it's kind of like a mini-map. Thank you. Yeah, a mini-map. So I think that would help a lot to show like how often somebody has like collaborated together over time. But the things that I've been struggling with is how to make it not too busy. Because there's so much animations going on at once that like people's eyes can get drawn into so many different directions. And I've been trying to focus all of the like eye drawing to down right here. Yes.
How did you do this project? Like this, did you like track every single video as they?
Oh God, no. So I wrote. I've been having a lot of fun with the YouTube API. So back about a year ago when I showed this, they were like, "Oh, why don't you just read more into the YouTube API?" Because I was doing something a lot more like painful than using the. And then I was like, I don't like reading. But this time around, I read the API, and I wrote the script that like pulls all of the videos and then like does the calculations of like, you know, who's collaborating with who. And the way that I figure out so it's not the most accurate way because I basically do a regex for all of the YouTube accounts that's listed in the video's description. So if a video says in the description like youtube.com, blah, 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 I take that and I assume that to be that they collaborated together. It's like, but they don't have any like this, like they don't tag channels like you would tag in Facebook. Like, so, yeah. Thank you. Any questions?
Can you tell me about the horizontal sort? Did you curate that?
Which horizontal sort?
So horizontal sorted? There's an order.
Yes. So that's just a very basic who joined YouTube the earliest.
I see.
But Jason and I, so we've also talked about how interesting it would be if you could like turn like lines on and off and like being able to reorder. There's like an idea I've been playing around with just like giving you all of the little circle pictures of all of the people that I have information for, and you can just drag in and out. But considering the fact that this has taken me about a year and a half, I think I'll just release it before that happens. Yeah. Thank you.
Oh, did you like tweet at Wong Fu and all the different artists writing up? I have some of them my friends, so I was wondering if you actually did.
So I did right here. So this was like an earlier version of it, and I took like a GIF of it, and then I tweeted it at them, and they never responded back. So I'm like, maybe it just means that it needs to be cooler before they'll respond. I don't know.
I'll send it to them.
Awesome.
The musician's not visualization.
Maybe now that you have sound on it.
Yeah.
Guitars, we're making music videos for other people.
Music videos.
Visualization works musically.
Sorry, what?
Yeah, that's a good way to hook them in. They could probably help with that.
So, the thing I'm struggling with is my 16-year-old little sister saw this and she was like, "This looks too smart for me," which I think is a euphemism for it's too complicated. And so that might mean that the general like audience target demographic of Wong Fu might not be able to like this. I don't know what that, because I'm guessing she's general target demographic. Like, yeah. Thank you.
Awesome.
Hello everyone. Just related to the outages that have been presented previously. I'm working on a non-profit that participates in internet infrastructure. So our project is to try to visualize all the outages that are happening in the internet in the world. So the idea is like to draw a map. I use D3 here with SVG. That just shows, this is just demi data, it's not real data. That shows where the outages are happening in the real time. And the idea is like on the requirements, we wanted to have it like clouds, real clouds that are drawn on the map. So how to make clouds on an SVG, that was pretty tricky way. So we end up finding a way how to do it with the filters on SVG. So when we added the clouds on the SVG, we had like this kind of result. But the issue is like on the requirement, we should have to zoom on the areas. So the compute was so heavy, so it was impossible to zoom. So say, okay, let's drop all the SVG and switch to another, like to canvas, HTML canvas. So the issue is like, okay, there's no filters as SVG in canvas, so how we can make the clouds in canvas? So the idea is like to be able to draw like little circles with different opacity to make this like looks as a cloud. I open source the code if someone is interested to draw like clouds in canvas, and then use some example from some blocks that's using canvas to draw maps. And this is like the result that we got like currently. We're still struggling with all the labeling, the label collision. If someone like want to give some help or some tips, it would be super cool. So yeah, that's it, like switch between SVG and canvas.
The shapes of the clouds don't mean anything?
The shapes of the clouds mean like the location of the outage. And let's say, for example, here, you can just give many location for one cloud. Like here, you can say, okay, this is like all the location of the cloud, and it's gonna draw like many clouds that make this shape. And you can like just like change the color, change the gray, add many circles and many other like customization here. Any other question?
Very cool.
Thank you.
Hi, I'm Chris. I work for Quantifine, which is a data science company here in Menlo Park. The thing I'm showing off today is essentially a table. Tables are great. They're ubiquitous and familiar, but they're kind of difficult to grep through and see trends and outliers if you have hundreds or thousands of rows. So this is kind of an interface to make it more easy to see trends and sift through your data. So you can do a lot of kind of functional programming methods. You can sort. You can filter. So this kind of goes along nicely with Miles's slide on kind of visually querying your data. So let's say we want to look at. So the data set is NBA players from last year. So let's say we want to look at players who are just in their 30s. And we can. Yeah. So and then we can kind of go through that data set. We can quickly go through, say we want to just look at centers. We can drag to select within the graph and kind of see where these guys lie in the context of other sorts. So like let's go back and we can group columns. We can use color to view a discrete dimension. And there's some additional functionality that I'm working on. We can see summary stats across columns, distributions that are hoverable and clickable. And if we want to focus in on a column, we can see a scatter plot of that column is the Y, and then the X component is the corresponding column. So like everything kind of lines up, so to speak. Yeah. And it's open source. It's still kind of a work in progress. But, yeah.
What's it called?
So I'm calling it a DataComb because you can kind of comb through your data easily.
Is that what it's called on GitHub? Or?
Yeah. So if you want to check it out on GitHub, it's under CM Pollis /DataComb.